In this video, we'll be looking at Lesson 26. Correlation does not imply causation. Definition: explanatory variable. Which we'll also call our predictor variable. In algebra, we talk about our independent variable. That's the x we frequently use. In statistics, we will use this term explanatory. That is, we hope to, when we look at two variables, we hope that we're able to use one to explain some movement or change in the other one. Predictor is probably a better word for what we use with regards to our regression, which we've already done, our least squared regression line. We use some x value to predict some y. Well, the y variable we call the response. The response variable is the dependent. The y variable. When we look at these relationships, we are hoping to take some x and predict some y value. Now we've already looked at correlation and regression. As humans, what we're naturally going to do is want to say that one causes the other. So our big question is, if we see a strong correlation, can we assume that x causes y? No, we cannot make that assumption. There could be other things at play. There may be lurking variables. At work. Or we could have the cause and effect flipped. And let's look at a couple of examples. We may observe that there is a relationship between ice cream sales and this, we could use this as our predictor, all right, and drowning deaths. this being our y. If we looked at this relationship, it would most certainly be a positive trend. As the number of dollars spent on ice cream increases, typically the number of drowning deaths is going to increase as well. Well, can we assume that ice cream is somehow causing drowning? People are eating too much ice cream and they're unable to swim. Well, no, that's ridiculous. Maybe drowning is causing the sales of ice cream increase. People are upset that people have drowned, that therefore they're buying more ice cream. No, that's ridiculous as well. There's probably some third variable, and this third variable, Z, I'm going to call it, it's the temperature, okay? And the temperature in this case is probably, as the temperature increases, the ice cream sales are increasing, and as the temperature increases during the summer, we tend to swim more. So this temperature, this third variable, is probably the cause of both of these. This third variable is our lurking variable. All right. Sometimes you'll hear that called a common response variable. It is indeed causing both of these things to increase. So just because we have this strong trend does not mean that both of these, that one is causing the other. All right, let's look at another example. The relationship between number of firefighters and the dollars in damage done by a fire. This too would almost certainly have a positive relationship. As the number of firefighters increase, the damage done is also going to increase. Should we assume that the firefighters are causing the damage? Well, somewhat. As the more firefighters on the scene, there are probably going to be doing slightly more damage to the building. But the again, the lurking variable is going to be the size of the fire. As the fire size increases, more firefighters come, and as the fire size increase, of course, the damage will increase. So in this case, this third variable, the lurking variable, is the size of the fire. Size of fire. As the size of the fire increase, so do both of these two particular variables.